Hi the figure, how you doing? I got a bit sidetracked, I'm so sorry. Oh, I haven't joined in the live one. Hi there, how you doing? Oh, that's weak though.
Doing good.
Really glad to hear. We haven't talked in such a long time again. Anyway, I'm gonna be rewriting the entire video on Bras and Kids today.
Nice.
Yeah. Yeah. I'm glad to hear you're good, Figure. I'm really glad you're good. I am very casually just off-putting my device.
Oh my god.
Okay. What would you say?
Nothing.
No, to go on, I just didn't hear you because I was talking.
I just said hi to Figure.
Oh, I see.
Yes.
Does this sound like... Okay, am I getting the notes here correctly? Listen, what does this sound like to you? Anything? Does it remind you of
Sounds like
anything?
piano.
Ah, damn it. This is my attempt at playing the Gravity Falls theme by ear.
Oh, I don't know that then.
You don't know the Gravity Falls theme?
No.
Oh, you... No. No. That's terrible. We need to fix that. Oh, damn it, my Windows isn't working. Alright, hold on. This has to be fixed. Are you not familiar with Gravity Falls at all as a show or just the theme?
Both.
No! 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 Terrible!
Okay.
Well, we'll need to amend that later. Okay, because I just realized something. I just realized that if I play this, it sounds very clownish and fiendish, and I like that. Oh, that's really good. I am, well, in my defense, I woke up like half an hour ago. So, you know, in my defense, there's a reason why I'm taking my sweet time to warm myself up to this stream. I promise I will be productive later. But we have a whole night ahead of us. Let me enjoy myself. At least a bit. We're doing a Make It Piano playing stream. Let me have this one thing. Okay. I haven't made a full pot of coffee, so we are gonna be productive, but hold on, because I wanna take this bit right now. Oh, we need to play something funky like that. That's gonna be challenging. That's gonna be really challenging because the left hand's playing in thirds. I am. Hi there, everyone. How are you doing? Welcome to this live stream. I may have gotten a bit distracted. 7 minutes of intro. I realized I can play the Make It theme in a clownish, fiendish way. I just feels too powerful to just leave it hanging. It's a lot more difficult than it sounds. Okay, fine, I'm turning it off. Jeez. Ah, fine. Unbelievable, I'm turning it off. Back to work. Oh, I suppose we can talk about the whole video to rescript. Oh, by the way, there's only I brush my teeth as one does. Oh. I work this through post. I immediately had a slice of apple. Oh, why? Why would you do that to yourself? And it tasted like orange. What do you mean? What do you mean it tastes like orange? I don't think you've ever had an orange in your entire life. Because I cannot imagine. What flavor is your toothpaste? If it was mint, then I cannot imagine mint apple tasting anything like an orange. Jeez. You don't even like oranges that much. I cannot. Oh yeah, this has to disappear.
Oh, I did it.
What have you done?
So you remember the document I wrote, right?
Yes.
Yeah. So I don't think I'll be able to do this because it's hard as fuck. But essentially, I'm trying to throw all of those proofs and I'm trying to translate them into lean. Like, it's... Do you know what lean is?
I've heard of it. Can't say I'm familiar. It sounds really
well,
familiar.
you're a programmer, so you'll understand. Functional programming, you have... Your theorems are essentially types, and you just put your hypothesis in there, you put the goal in there, and then you prove the stuff. And then if your program type checks, then that means your proof was correct. Otherwise, something's wrong.
Oh, that's really clever.
Yes, it's called homotopy type theory, if I'm not mistaken.
Oh my goodness! What? Wait, it's open source on GitHub.
Yeah, and obviously it has to be open source. Like, it has so many theorems. It has, like, I think easily tens of thousands of theorems that everyone's contributing to and stuff. Essentially, it's just an entire project to formalize all of mathematics.
That is incredible. Where's the goddamn? Where's the GitHub link? Oh, give me GitHub. How was I not aware of this? This is incredible.
It is. I tried doing this 3 months ago, but then I got incredibly bored because it was genuinely hard to get into. But now I'm gonna try to get into it again to accompany the papers that I'm writing.
Wait, which one is the true lean?
What?
Theorem prover, lean,
No,
theorem
no, no, no,
prover.
no. No, that's a trading engine. What the fuck is that? No. Search lean prover on Google.
It's not this lean?
No, not this lean. Just search. I don't think you'll get it like this. Just search lean prover. Oh yeah, no, you're already here. Yeah, this is it.
Yes, that
Your
is the
stream.
lean.
Yeah, your stream is a bit behind, so it's a bit.
Okay.
Yeah.
So now the question, which one is the lean? 31k, I'm gonna guess.
Lean prover 4. Yeah, the lean prover lean 4. Wait, it was
Oh,
there, but
found
no,
it.
it's not.
Written in lean, that's comical.
Yeah, there we go.
Written 94% in lean.
Yeah.
Yeah, it's just phenomenal. I just out of curiosity.
Yeah, well, you should work on the videos first. I can tell you about this more later.
No, because I just out of curiosity, I'm just. They made their own language for this, which means there has to be some kind of interpreter slash compiler in there.
Yeah, they have their own thing. Like, you have to be connected to the internet because apparently there's a server or something. I don't know the details. I'm not a computer scientist, but I'm just using it.
Wait, so this lean is only the. They have a header file. Hold on, let's consider this. Show me. Source util. Oh, a lot of these are non-existent. So this is just the. Let me see. Programming language and present labels. Okay, but it's a programming language, means you must have created some kind of interpreter slash compiler slash transpiler.
I mean,
So where is it? Oh, there's a GitHub link. Ah, there was a GitHub link in the corner the entire time. Good to know.
I wouldn't be surprised if the compiler slash interpreter is pretty basic. Because if I understand things correctly, like every time we write a theorem, we essentially create a new type, like you would a string or a int or whatever. So every theorem is essentially a type, and the way that you check if a theorem is correct or not is that you try to instantiate a term and prove that a term exists, right?
Okay, in
So,
mathematical terms, I'm saying that's fine, but in computer science terms, I don't know if a computer science, if a CS type is the same as a mathematical type. Because in a computer science terms, when you say a type, what you usually mean is you mean that you have some kind of like a blueprint of ones and zeros. So,
Hello.
hi the macaroni. So, when it comes to if your type is an integer, then it's just a blueprint where each consecutive 1 0 is just addition of 2 to the nth power.
well, yeah, no, I'm sorry, this is beyond me. You can actually ask Alu about this because it's all type dependent theory stuff.
I am because so like from what I'm looking, they made a whole language which would require interpreter or transpiler. It doesn't look like that much of a trivial one.
I don't know.
Because
I can show you the code that I had to write to prove, and maybe you can make some guesses off of that.
this looks so mundane. I genuinely don't know if I would be even able to make any educated guesses.
Yeah, it's weird. It's not like your general programming language.
Dynamic type information. Types with an instance of type name can be sorted in a dynamic. The type class contains declaration name of the server which does this variable. Avoid declare instances establishing the morally this is the same as morally this is the same as class type name alpha type where unsafe case alpha type. Okay, we're getting sidetracked because I wanna see introduction, getting hello world. Yeah, that would be good. Running a program. Yeah, that's pretty standard. Functional programs effects. This is pretty simple. It's all functional programming.
I mean, I don't know. I watched a video series on it. I don't know. Yeah, I'm not computer scientist. I'll just.
Basically, how should I put this? Functional programming is more when you handle everything in terms of the operations you do on things rather than the things themselves. So normally you have a number. When it comes to functional programming, you're talking about more of it in terms of operations on that number. It's a lot more tricky and difficult to implement, easier to work with though. So for example, yeah, right here the functions are just treated as variables, which is honestly impressive. Because I mean, yeah. Two brokers responsible. This is mental. You put string of how would you like to be addressed, then the input is the get line, and then let name be this. That is relatively simple. But once again, all of these are functions. A standard input output. I am honestly more interested in something a little bit more out the box. List of strings. Which commands can be extracted? Yeah. This all makes sense. The notation is funky, but that's just notation. That. Oh, that is mental. Oh, that is mental.
Alright.
Oh, ho ho ho. Ho ho ho. Oh, that's something I haven't even. I don't think that's something. Goodness gracious me, that's something I wouldn't even be able to do in C.
What is?
this line right here, which is
Hold
writing a proposition of 1 plus 1 is 2, colon 1 plus 1 equals 2, and then RFL.
RFL, yeah, reflexive, yes.
The reason why I'm saying that this is not, like, I don't think I would even be able to do it in C is because, in this case, what you're starting with is basically your, like, variable for a proof. Actually, well, functional programming, doesn't matter. So this is basically like the handle for the proof, then the logical statement, and then the actual proof. I don't know if I'm getting this right exactly.
Yeah, you like the way you do it, you write a hypothesis and you write your goal and then you do the proof.
Yeah, so in this case, the hypothesis, that's just what you call it, which can be whatever you want. Then your goal in this case would be 1 plus 1 equals 2.
Yeah.
And then the proof is everything that follows colon equals.
Yes.
Well, the reason why it's so mental is because the colon equals, in this case, functions as a sort of setting operator, let's call it. So you set a variable. So normally in programming, when you create a type, you like, I can give you, by the way, a stream on Discord if you don't want delay.
Oh yeah, that would be nice.
So basically, normally the way you do things in programming, so let's say we have char A equals 7, right?
Yes.
Normally what you do is, on the very beginning you have the type, which allocates some amount of memory, and also specifies how that memory should be operated. Then you have the operator that sets it, in this case the equality, and then you have the 7. So what this would mean is this would mean 1 1 1 0 0 0 0 7.
Yeah.
Did I get that right? Yes, I did.
Yeah.
So that's simple. In this case, however, when it comes to this proving mechanism, you would need to find some kind of way. You would need to think of some kind of way. This goddamn, like, implementing it is one thing. I don't even know how I would go about planning this sort of thing. Where, as far as I can figure it out, the char A, or the A itself, I suppose, is taken care of by this define 1 plus 1 is 15. That's just the name of your thing, that's simple. Then the type would have to be handled by this.
Yes, your theorem is the type, yes.
And goodness gracious me, how do you tackle that? Basically, you would need to. I'm gonna basically like explain to you in as mathematical of terms as I can, like, where.
And I know a tiny bit of computer science, like.
Yeah, but I'm really trying to convey why it's so mental, because basically. Basically, you have like lambda. I don't know. I personally use lambdas. This is lambda, right? I just woke up, so we have to cut me some slack. I personally use lambdas to represent like empty fillers that can be anything. So sometimes values, sometimes functions. So whenever I don't feel like, so whenever the proof for what I'm describing is you have eyes, I just use lambda. So basically, this is like a structure of name of the proof. That's trivial. That don't matter. That we can disregard. Then you have the goal of the proof and then the proof itself. These are the two things you want. Now let's just disregard the goal, the proof itself now, and let's just focus on the goal, and that is it. In that case,
well, there's also hypothesis. Like in this case, there's no hypothesis because 1 plus 1 is equal to 2 is. You don't need an assumption to prove that, so there's no hypothesis.
Yeah, so case, but it gets okay. So it gets even more complicated. That is mental. So, but for now, let's tackle the simple case. So 1 plus 1 equals 15. What you basically want is you want to find some kind of way to encode 1 plus 1 equals 15, or more specifically, a general logical statement, so that later on it can be compared / checked / evaluated, anything like that. And this, I'm guessing, works for almost any kind of logical statement.
Yeah, you can check the chat. in
Yeah,
the
I know.
group
I
of
already.
what yeah.
So yeah. So in this case, fa plus integral t in a x. Am I getting it right?
Yeah.
Yeah.
Yeah, integral over from a to x basically
Yeah, and the
of the
thing.
derivative of f.
Yeah. The thing is, how would you encode that on its own? I would already fail at that point.
I mean, it's pretty fucking crazy. I have no idea either. I'm just using it.
My goodness, this is genuinely impressive. This is a
And what's crazy is it works for all fields of mathematics, like group theory, category theory,
yeah. If
functional
it was just
analysis.
arithmetics, that's comical. That's easy. If it was just algebra, that would be okay. Yeah, that I feel like even I could do. But it working for like any field is what throws me off, because I cannot, for the life of me, imagine a way to basically store a logical statement in a way so that it can be algorithmically, like, I don't even want to say evaluated, because I don't think it will be evaluated. It will be just checked.
Yeah, it will be just simply checked. It's a type check essentially.
I genuinely don't know how that kind of type check would be achieved. So for example, let's just do trivia once again. 1 plus 1 equals 2. If I was only working with equalities or inequalities, that's doable. But that's only because the way I imagine doing it is just finding the equal mark and then just evaluating both sides. But that only works for equalities and inequalities. With constants, I should also specify. It doesn't work with variables. With variables, there is no like sure way to solve any arbitrary equation, because they can get funky. There are certain points at which you can algorithmically solve simple ones, but especially if you chuck in an integral in there, that's gone.
Yeah.
There is no algorithmic way to solve for any kind of differential equation, which is why if we had that, physics would be just 3 times more solved, because what is it that you want? Just would you like an, I don't know, carbon atom? There, congrats, you have it. This is mental. I find this. I will need to look into this more, because this, from a computer scientific point of view, it is just really impressive.
What's funny is it was like, I think somewhere between the 2000s and the 2010s, some homotopy theorists, like people who study homotopy, they were like, this looks like type theory. And then they essentially just made homotopy type theory, and I think that's what I'm doing right now. I don't know what's the difference between regular type theory and homotopy type theory, actually. Also, what's funny is that it can parse all Unicode characters, so like the integral sign and stuff.
Okay, parsing all Unicode characters is it's neat, but that's not something that would get me off my rockers. This does get me off my rockers. This is just driving me mental. I want to know more about this now, because it's just, goodness gracious me, I'm motivated. I'm motivated to
Prove mathematical statement.
No, normally work, because if I know that this is like the level that people reach with cool stuff creation, that's mental. Absolutely mental. Functional programming on its own is really fun, but I really like low-level functional programming. I wouldn't even. This goes so far beyond. This is the most functional I've ever seen. It's mental. It's absolutely mental. Okay. Just really briefly before we go on, I'm just out of curiosity, what? Oh, my absolutely terrible coffee. No, jeez.
Anyways, I think I should go back to irradiating myself with multiple mega C words of radiation.
Too many bananas.
Yep. If you ate 40,000 bananas, the radiation would kill you.
They had the YouTube channel of the Leapfrog community has 4,000 subscribers. That is criminal. I need to. Oh, I need to collab with them. We need to collab with them.
Collab with them, bro. Those 4,000 people are like Ivy League students or something.
Exactly.
They have, like, they have like a crazy amount. Like, dude, have you looked at like the proof bank, like the documentation? It's fucking crazy. It's absolutely mental.
I haven't looked through anything yet.
But I'm still having like basic syntax problems and constantly like.
I want to know more about how they did what they did. I want. This is a miracle. I genuinely cannot stress. Hi, this time. Hi. I cannot stress how most of the things in computer science, really often, it pains my heart, but it's the standard thing where people get excited over mundane things, and then don't recognize like incredible things simply because it's really difficult to know what is incredible, what wasn't. I'm certain you've come across this in mathematics as well, where you say some kind of like mind-blowing fact to someone and they just don't care because like you need to explain why it's mind-boggling first.
Yeah,
I don't want to complain about it because it's reasonable, right? The craziest of facts require a whole explanation for why they're crazy. This is genuinely one of the most interesting projects, computer science related, I have seen, either in years or ever. I can't really recall anything else that was so.
I mean, it is a pretty damn big hot topic, like everywhere. Like I heard someone, they got like a 5-year, I think either a PhD or a postdoc position, and all they have to do is translate Fermat's last theorem's proof into lean. And they have a 5-year like funding to do that.
It is incredible. It is incredible. I want.
It's a pretty hot topic.
It clearly is. Jeez. Oh no, because I'm It was first implemented primarily in C++, yes, okay. In lean form, which was in place of lean theorem proof capable of producing C code, which they compiled and developed an efficient. It's a cross compiler to C! Oh.
Damn.
Oh, I'm sorry, but C takes the cake again. I don't know what to tell you. It's a C. It's a C. And proof time class synthesis memory management procedure will be definitely command the ability to avoid touching C++ code. That's incredible. Absolutely incredible. I like this a lot. I do like this a lot. Oh, I've never heard of this before. Mr. Explanation of what you guys know. Do you mind explaining pretty please? It's difficult to explain. Okay, so lean. Ash, would you like to provide a brief explanation of what lean is? Just something really short.
Yeah, so essentially in maths, the place we're at now is that mathematical proofs are very long, very obscure, very abstract, especially if you look at fields like homotopy theory, any sort of algebraic topology field. And essentially, the problem we're running into is that we need people to peer review our proofs, but not everyone has the capability to peer review proofs, and there might be human error. That's very possible. So what we want to do is we want a computer to check whether our proofs are correct or not, and Lean is essentially basically a computer assistant proof checker, and then make it can take it from here.
Yeah, so Lean is effectively proof checker, proof assistant. The problem is that when it comes to mathematics, it's 9 times out of 10 is an understatement. That's so cool. You don't know the half of it, Stump. Because when it comes to mathematics, 9,999,999 times out of 10 million, when you're talking about something in mathematics, it's not algorithmically verifiable by a script. So most of the time, and when I say most of the time, I mean most of the time, when you're talking about something in mathematics, as you can also, if I say anything wrong, do correct me. But most of the time when you talk about something in mathematics, you're just talking about a set with something defined on it. Set for capital S for set and lowercase s.
So just to add on to make its point, we regularly, routinely, prove theorems for all x or for all real numbers or for all of a set, and that set is usually infinite. So it's not quantifiable.
Exactly.
And run an algorithm to check everything.
The really tricky bit is that this combination of set and something defined on a set, as far as I'm aware, isn't algorithmically implementable. And even better, set on its own is impossible to implement. Because set on its own is so vague, there's just no way to represent it in computer science. There's no way to just say you have a set that says nothing. You need some additional restrictions. So for example, the easiest example would be metric space. Metric space is a set with the notion of a distance, if I'm not mistaken. I'm pretty certain it has some additional things, but I could really easily check just to make sure I'm not metric space. I think it was just a set with a distance. Metric space is all the pair where M is a set and D is a metric. Yeah, okay. So you have a set with a metric space. And so the easiest example of that is any coordinate system in existence. If you've ever played a video game, right, your set is just R3 and your metric is the distance function, which most of the time is the Pythagorean, because that's the easiest one. That is trivially easy to model. Why? Well, it's because an element of this set would just be a 3-dimensional vector. That's it, x, y, z. And even better, that's it! You don't even need to care about the distance, because as I mentioned, distance is the Pythagorean. It just follows. It's trivial. So that's easy. However, when you are talking about something like topology, which, once again, if I'm not mistaken, is just a set with a topology. Just yeah.
It's a set and some subset of the power set of that set.
Exactly, what are sets? That, good luck modeling that. Because in this case, you need a notion of closeness, effectively. So when you have two elements of a set, there can be an element in between them, but there is no distance between these 2 points. So when you have, not even points, elements. So when you have these elements of a set, you cannot represent them, or it's not that you cannot represent them with a vector. You can represent them with a vector, but you cannot think about them as points in space, despite the notion of closeness still existing. And that is a bitch to implement. That is difficult. You can't even talk about implementation much here. It's more that you evaluate it differently. And this is just, and I would just like to mention that these are just 2 of the most common kinds of sets. That's just 2 examples. There are infinitely many more. And the thing that's mental about this is that with Lean, you need a system that works for all of them. Even more, this is just a fraction of what it should be able to do. That's why it's so mental, because I genuinely... You could give me just an unbearably long time and I still don't believe in my ability to make this sort of system. It is just... It would take me days to explain just why it's as impressive as this. Hi Derola, by the way, hi. It is incredible. Because how do you represent a logical state? So, you know, when you're talking about set, once again, this is the simplest example. I imagine you can define this kind of pair in Lean, Ash. Can you?
Sorry, what? I was...
Can you define a topology in Lean?
Obviously.
Yeah, obviously. I figured that's the one to double check. In that case, what I would just like to mention is that in this case, in order to that, you have some kind of topology, and...
Oh, what's even more fucking crazy? I said that a topology is a set and some subset of its power set.
Yeah.
But usually when we deal with topology, we don't say that, okay, this is our set and this is the subset of the power set we're dealing with. No. We usually say, okay, this is a topology, and we say that sets of these form generate the topology. Which is even more fucked up than having some fixed number of sets or some fixed set. We say,
Exactly.
no, these types of sets generate the topology.
Okay, Stump, I think I have a... I'm pretty certain by now you probably understand what I'm talking about, but I have actually a brilliant example I just thought of that actually perfectly encapsulates what I'm talking about. And I'm honestly really pleased with it. When you're dealing with programming, right? And you have a function, totally in no way, shape or form related to the video I'm just making, you have a function equal to x squared. If you want to get its derivative, it's trivial. You can implement that easily, because you can have that function and you can define the derivative of that function. I know that you've probably got it by now, but I'm really pleased with this analogy, so hear me out. You can define the derivative of that function as just 2x. Trivial. Both x squared and 2x are trivial to make in any programming language in existence. However, this only works because getting the derivative you did yourself as a human. You had to actually put some mental effort and get the derivative. If you wanted to create a generalized method for getting derivatives, right, then you would need to do it using the good old equation f of x minus h, plus h, sorry, minus f of x by h. And this you cannot evaluate, because in order to evaluate it, h would have to be a 0, which it cannot be. It cannot be a 0 because then you're gonna get division by 0. To which you might say, make it, just take a limit. Yeah, that's fair. One issue, however, computers can't take limits. They just can't.
Yeah.
You can decrease h, but that only works for functions which are not chaotic. That only works for functions which, like, you could just lower the h, but every single time, no matter how low the h gets, you are making the assumption that basically the result of this entire thing, the value for this, let's call it capital V, you make the assumption that V, like, approaches something. Or not even that it approaches something, only that... I'm thinking of a way to express it mathematically. That or you could just say that you make the assumption that the second order derivative gets lower as you approach 0. I'm pretty certain that's...
Sorry, is there something you wanna... What?
What happened?
No, never mind. Carry on.
Yeah, so so this is the kind of problem that I'm talking about here, where if you're talking about derivatives, it's basically that you need creative thought in order to solve them, which is that there is like... You have this notion, you have many of these notions in mathematics that are understandable concepts but aren't exactly computable. Stuff like sets, which already pretty big deal. Stuff like geometry, that's another one, not computable. For example, imagine a sphere. You can imagine a sphere easily. You can imagine curvature on a sphere. You can do all sorts of mathematics with a sphere. Computers can't, because, well, yeah, they can approximate a sphere. They can compute the results of calculations you've done in the sphere. They cannot actually compute a sphere on its own. Limits is another one. Infinitesimals in general. Basically, almost everything that's not linear algebra is not actually computable. And so that's what, this is just mental. I am so amazed by this. This is incredible.
Yay.
Oh, I got so distracted. I was supposed to be scripting the linear algebra video and working on the derivatives video. Oh, I need to cut this entire thing as well. It's irrelevant. Actually, no, let's not cut it. Oh, this is that is a great detour. Ash, if you're gonna get things to distract me from my work, get more like these, because this was brilliant.
I don't know. Right now I'm just trying to figure out what the fuck is wrong with my syntax.
Also, kudos to you for actually learning Lean. That's because it genuinely seems like a impressive is one thing, but also an extremely useful tool. So it's good that you
It
are.
is useful. It's useful because if I'm going to publish stuff, I'd like people to have the confidence that what I wrote is in fact correct, and this is essentially just going to be the stamp that it's correct.
I like that. I like that a lot. Oh.
Also, yeah, it is very useful, and not many people know it. It's not new. That's the thing. It's not new, but it hasn't caught on either. So
See, that's the thing. That's why I said we need to collaborate with the Master Foundation to spread the message.
yeah.
We can. We could. I'm just saying we could. You truly. Because wait, hold on. Did I get that right? That you this whole entire conversation started because you're trying to leanify
My paper, yes.
your paper that you wrote, the one from the thing at the guy of the place.
Yeah, with the Taylor expansions, yes.
We could just like contact the lean maintainers and just we could just contact them.
Okay.
Just saying, hey, here's the deal. So Lean is a programming language that is built to do proofs. Lean is a programming language that is built to, as far as I understand it, check
Verify
proofs.
proofs.
Yeah, verify.
Yeah.
You cannot, to say that you cannot have a program that, to say that you cannot have a program that makes proofs is an understatement. Because I'm pretty certain that's even mathematically provable that you can have some set of all sets sort of thing. Wasn't there a thing where I don't remember what it was called? It wasn't the holding problem. It was something else. Doesn't matter. We're getting off topic. Doesn't matter. Too much mathematics. Language that is built to do proofs. It is built to do maths effectively. Like, how should I put this? Oh, I have a good one. Basically.
Coincidentally good? No, it's not coincidentally good. It was built with the intention to be a math theorem prover or verifier.
Quick double check on, just to make sure I'm not making a mistake. When I say algebra, what is it? Algebra concerns itself with algebraic structures and the manipulation of expressions. Arithmetic. Or arithmetic. No, arithmetic would be a better word for it. Think about it this way. Stump. Hi there.
Oh, Stamp is here.
Yeah.
I
Hi. Stump, think about it. Wait, first of all, what are you familiar with any programming languages? If yes, then which ones?
Not really, no.
Okay, that's fine. In that case, I'm just gonna give you like a really brief explanation of mathematics in Python, which is that when you have number x plus y, that's a sum. When you have x asterisk y, that's multiplication. X double asterisk, that's powers. And then slash is division, minus is subtraction, and then finally, importantly, brackets work. Right. So this, can you see slash here, have you heard what I just said?
Yes, yeah.
Okay, so you can think about it this way. The reason, I know that what I wrote down may be just idiotic because arithmetics, right? But the reason why I wrote it down is because if you define your rules clearly, then you can compute any equation using these operations. And the reason why it's important that you note down the rules clearly is because if you have an equation, something like
Wait. Don't you need square root and logarithms?
square root is powers. And logarithms
Well, yeah.
and logarithms we're excluding for now because they come from an additional package. They're not in the byte. You surprisingly don't need logarithms all that often. I could also mention like, you know, trigonometric and such, but we're talking about basic, really basic arithmetic here. So this is it for now. Basically, using these rules, you can compute any equation. So basically f of x, you can get that for any given x. What you cannot do, however, is you cannot solve any equation. So if you have even something like 3x is equal to 5y, and then, I don't know, something, another line, I don't know, 2y is equal to x, that doesn't work. Doesn't matter. The point is, if you have some kind of equation, you cannot solve it using Python. Python cannot solve it. Does that make sense?
Yes.
Right. Well, the question is, why can it not solve it? If it can compute anything, why can it not solve? If it can compute an equation, then why can it not solve an equation? So if we throw 3 onto the other side, and then if we get x is equal to 5 by 3y, right? Then Python can compute the x really easily. So why can it compute this but cannot solve this?
I have no clue.
That is fair, because well, it's something people don't usually talk about. I a really long time ago made a whole bunch of videos on the topic because I just am always was really fascinated by it, or not fascinated but liked it, which is the difference between computation and calculation. Computation basically means that you have like a set of rules that you follow. When it comes to calculating, however, you don't have that set of rules. You have logic, which you can do, but so basically in this case, in the bottom case, Python follows a very strict and specific set of rules and set of steps. So so you give it some kind of y, and it first multiplies that y by 5, then it divides that y by 3. It's very specific. So Python knows exactly what to do. When it comes to the top one, however, there is an infinite amount of things you could do that all theoretically would bring you as close to solving this equation if you don't know what you're doing. So the question is right here, for example, at the top, why should we bring in the 3 to the other side? Why should we not bring in the 5 to the other side and solve for y? Both of these are equally valid. And so that's the point. If you have any arbitrary equation, because obviously you could still algorithmically implement it for simple enough equations, but if you have any arbitrary equation, there's a point at which there is no like, there are no objectively right moves or objectively wrong moves. So in that sense, with Python, you can check if your equation got the right result. You cannot solve that equation, however. And I imagine that in the same sense, when you have lean, you could check if you have some kind of logical flaw in your reasoning, but you wouldn't be able to generate that logical reasoning. Because checking for a logical flaw is an algorithmic process. Creating some kind of line of reason, that is a creative process. You have infinite amount of options to choose from at every step. You need to actually think of what option to choose from. The thing that's mental is that still requires some kind of method to model every single object in mathematics, Herculean task, unless you are really goddamn clever, which is why I'm so impressed with it. There's just something. It's just truly something. I genuinely mean it when I say, by the way, that we could contact Lean and then ask about. Like, listen, I don't need to be a guy, but if Lean needs to be more popularized, then I do know a guy who happens to be a founder of a science communication charity who would be glad to communicate some science. Slice it on the x-axis. Now this won't be the slope anymore when we're slicing it that way. Only it will be... Well, it will be kind of the slope, it will be just a different kind of slope. It will be an inverse slope. Or flipped slope, rather. This function is bloody confusing. Oh my goodness gracious me. It is so mental. I can't get over the lean thing. I am so impressed. I really wish it's not that I'm just misunderstanding what it is. I don't think I am, because even the code, yeah, because
pretty impressive.
Even the code you provided on its own would be meant to implement. The map, god damn, the variable, the first line, variable.
Yeah. It's a map, yeah.
It's a map from R1. I'm guessing this is R1 when you don't.
Yeah, R1.
R1 to R1.
Yes, that's what it's written.
God damn, this isn't like as a function. That's pretty fair, I would say, but the implications there are mental, because this R doesn't have to be an R. It can be whatever. Oh my goodness.
You can also write it from any set to any set that you have defined.
That's the mental thing.
Oh wait, okay, so
from R to R would
so
be...
it's just like you just tell it that this is a transformation, and then it just like this is so hard to describe the thought that I've had.
Yeah, basically like you prove something and then it checks if you have made any logical errors in your proof. So, you know, you write out your long equations, and then it goes through these equations and finds, hey, this right here is wrong because you said that 1 plus 1 equals 3, or something like that. Except this is oversimplifying it extremely, because god damn is it difficult to do with a general logical expression. Hold on. I need to message Alu. Alu, hope you don't mind the ping, but have you heard of this thing called lean?
I'm pretty sure they have.
I would imagine so, but I still nice to double check.
Because they've been doing type theory for like the better part of as long as I've known them.
Damn.
Why did I write and here? This is a star. Sorry? No, wait, I don't mean this. Okay, I have formulated the theorem. Only took me like 30 minutes. Now I have to actually prove it, fuck.
See, but what a 30 minutes was.
At least I'm learning. This is like my first exposition to it after 3 months. And I did not do this shit prior 3 months. I was just doing basic, oh, this is two real numbers, add reflexive or add arithmetic or some shit. Crazy stuff.
Oh, this... Oh, I did this like an... Oh no, I didn't do it like an idiot. Never mind. For a second I thought I did like an idiot, but then I realized that you can't actually take a limit as the approaches to 0. Never mind.
Prove the IBP lemma for one step. Okay. By the way, I can show you how Lean shows me what I'm doing if you're interested, because you are interested, so.
I mean, I am interested in how they got it to work. I am so interested in that. 'Cause that
So-
is... I just...
In the thing you're seeing here, F, A, and X, and N, these are like global variables. We call them context. This is the context, right? And then HF is my hypothesis. I'm just saying that we have a function that's n plus 1 times continuously differentiable on R on a compact set A to X. And this is the statement. So that was my hypothesis part. And now the statement is essentially the type. The type is integral from A to X of x minus t raised to power n factorial blah 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 is equal to blah 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 blah. Essentially the identity I want to prove. And now I'm gonna have to write a proof for this.
That's brilliant. Two things. First of all, I really... How long ago did you start learning it?
See, the thing is, I know what it is on a basic level because I knew it 3 months ago. But then I only learned it for like 2 weeks and then I dropped it because I was super busy with other stuff. And now I'm starting it again.
I have to say, I genuinely wish I could use my like computer science knowledge anyway, but you are just straight up ahead of me on this. This is so much different from any normal programming you would do. And second of all,
Yeah.
I know that you're a huge fan of number theory, so this is gonna stick with you. But like to me, it feels like imagine if you found a website on the internet that was just a function into which you input a number. You input that number and then it instantly gives you back that prime. Like that's what I feel like right now. Okay,
Damn.
you're not gonna use it personally. You're not gonna like personally use a function that gives you a prime. But god damn, would you want to know how it actually gets that prime?
Yeah, that's true.
That's what I feel like. I don't think I'll use lean, but my goodness, I want to know how it works. Ah, jeez, what am I doing? Right, this... Wait, no, this, because this is normalized, right?
Okay,
Why you like this? Why you like this?
yeah, I'm gonna have to write this all on paper. So I have
It's actually a pretty funny display of what I'm talking about in the video. I would like, so this line right here is meant to be a graph of the function. I would like you to guess at which point h is equal to 0.
Wait, hold on, let me tune in. At what point h is equal to 0?
Yeah, guess at, this is the line. This right here is the line. Guess at which point, we need to look, show it from the side, there we go. This yellow line, guess at which point h is equal to 0.
I don't know where they intersect.
No, it's just completely normal, and then on accident Blender just get h is equal to 0 and a singular point drops down, and then it just keeps going as if nothing ever happened.
Yeah, intersection. Okay.
For you,
That's
actually,
funny.
yeah, it's a convenient example. The only problem is I don't know why it's going at such a ridiculous mental angle. Should we divide it by itself?
Ew, no, this is not the statement I want to prove. Yeah, this is not. Is it? No, it's not. Okay. Let me.
What is this? Divided by. Uh-oh. I have messed something up badly.
Yeah, orange, there's 1, and then everything is minus. So this is n minus 1, n minus 1, and this is iterated derivative n, and this should be just n. This should be just n. Okay, this is now correct.
Okay, I know what I messed up now. Oh jeez, I am genuinely so whiplashed by this lead thing. I love science so much. Oh, god damn. I love science. Darwin, damn.
Oh my god, how the fuck am I gonna prove this for the operator valued one? I'm gonna have to deal with proper topologies and stuff. This is highly non-trivial. And it makes sense why people are not using lean all that much. It's because, like, holy shit, is this annoying.
Well, I mean, I don't mean to be that guy, but like, if you want to perform a miracle, I suppose slight annoyances might be on the way, you know?
Yeah, but I don't like annoyances.
It does feel like something that's has incredibly high skill floor, but at the same time is unreasonably useful.
It is unreasonably useful. If you have 100-page proof, trust me, no one's going to peer review you at all.
Right, make it video, Braznakets. I'm going to do the thing where I just highlight the entire video in red to mark the fact that it is in fact scrapped, and I'm just gonna rewrite it completely. Actually, I like the joke of what is a vector? Vector is something that operates like a vector. I like that bit. I want to keep it.
Bye. Okay. Next one is
Asking what is a vector is like asking what is a woman.
yeah. Holy shit.
Okay. What is a woman?
Something that operates like a woman.
Yeah, something that transformed. No, no.
I can see that
Horrible.
honestly. What is a woman? Or something that behaves like a woman.
Horrible joke. What the?
Oh, someone just joined the Discord server. I get so excited because I thought that Alu replied to my ping.
You get pinged every time someone joins the.
Well, not ping, but you know, it highlights that there's new message in the welcome channel. I should mute it for myself, that's true. There we go.
How the fuck did this work again? Oh my god.
There's gonna be only two sections. Linear algebra, background, and then analogy for states. I'm still really pleased with the analogy of filters. I think it's honestly one of the better ones of this entire project that I came up with. A vector. Well, a vector is something that operates effectively. Actually, for this segment, because I was doing... or maybe doing it twice would be a bit much. How do I explain matrix? Express easy. When you have a brown, you have a cat. That's basically your linear map applied onto your... Yeah, that's your linear mapper and your linear mappee. When you chuck in a matrix, however, that's a set of linear maps, which... how would I explain this? Because when you have a matrix, when you apply a matrix onto a vector, you get another vector to dot. the vector.
What the fuck?
Oh my goodness, what kind of maths are you doing?
Some kind, apparently.
My favorite. I like how the process of me making videos and making explanations most of the time just involves me standing silently at my PC, looking at a single equation and just unblinking in complete dead silence.
Yes. Relatable. Oh, there we go. Fucking hell. Okay, now time to type this up in lean. I'm gonna be so lean after this.
Kind of like at the corny bar, I swear.
Okay, what theorem do I need to apply first?
Fun fact, by the way, in my code, I have a pocket that I ripped open specifically. It's my exclusively corny bar pocket. And I genuinely ripped it open when we were in the parking garage. When we were parting our ways, I ripped it open, and since then I've only held corny bar in it, which means since I got the code, the only reason why I used that pocket was for the corny bar.
Wait, you still have that corny bar? Didn't
Yeah!
it end with RAM?
No, I still have it.
Oh my god.
I'm not getting rid of that thing.
Crazy.
I'm used to make the corny bar tracker.
Okay. So I integrate that with respect to key and I get... Oh my god, there are so many identities that I'm gonna have to type up.
Okay, no, I don't have a good idea for how to explain matrices. I'm just gonna explain them as a whole bunch of vectors or covectors, depending on where they are.
Ah, it's negative.
What else do I need to mention for this? I suppose I shouldn't make the video unnecessarily long. Short and concise better, especially since I have a very limited amount of time to finish it. Yeah. Goodness gracious me. Alrighty. I think I'm gonna go and eat something extra. I had a lasagna today. That's
Damn.
what I got when I went. Yeah, but like a small slice because they were on a sale. And it only now hit me that this is the only thing I actually had to eat all day.
I haven't eaten anything either. I should probably make something, but I'll see.
Go do that. I'm gonna go and eat something as well. Anyway, I would like to say but I mean, come on, just one person watching, and as they have been for the past half an hour, so I don't think anyone's gonna be too upset over me ending this live stream so short. And for now, that'll be it. Thank you very much so much for watching, and have a great day. Bye.
Bye.